Okay, I'd like to talk about ellipse again. Here's our ellipse, and the ellipse is what? It's a set of points that the sum whose distance, let's say this point here, the distance from these F1 and F2 and these points are called focuses, or plural is foci. I've got a focus. Any point, its distance from each focus is a constant. This distance here plus this distance here equals the same as this distance here plus this distance here. And then we'll kind of cover that again tomorrow. So, all right, let's talk about, this is a horizontal ellipse. That means it's kind of flat and pancake. Notice this is my major axis. The major axis is the big axis. This is the minor axis. Here's the center. Okay, the distance again from from my center to a vertice, to the edge of my ellipse is A. So this distance here is A. Notice my vertice. Here's my vertice over here, and also the vertices. I have two of them. It's the intersection of the ellipse and the major axis. So right here is a vertice, and right here is a vertice. Okay, notice the ordered pair here is this ordered pair coordinates are negative A, 0, because this distance is A. So if I go this way, if this distance is 5, this would be negative 5, 0. Okay, so my vertices, the intersection, the ellipse, and the major axis, the distance from the center to those vertices is always A. The distance from 0 to the edge of the ellipse on the minor axis is B. So from here to here is B. From here to here is B. But as far as coordinates, again, this would be 0B. This is 0, negative B, because we're going down on the y-axis. Okay? All right? Notice the distance from F1, my two focuses, or foci, that the ellipse is made off of, F1 and F2, this distance from the center to either focus is C. Okay? All right? So this distance here is C, and notice this coordinates for this point would be C, 0, and for this focus here would be negative C, 0. Okay, A is always bigger than B, and B is always greater than 0. We will frequently use this B squared equals A squared minus C squared. Pretty much every problem we have to solve for one of those three. All right. Notice, if I go ahead and another component is this. I want you guys to, I've covered before, that this here is C from my origin to my center, from my center to one of my focuses. That's C, and here is the distance B. We know that from here to here is A, but also the hypotenuse is A. If I draw a right triangle connecting B and C, that hypotenuse is the same distance A as this distance A here. Okay, and that's why we can use this formula on every problem. Right, here's a vertical ellipse. Here's my major axis. Here's my minor axis. Notice the vertices and the foci are on the major axis. Here's from 0 to the center, which right now is at the origin, 0, 0. From here to here is A. From here to here is A. Notice my coordinates. Vertice 1, 0A. Vertice 2 is 0, negative A. This point here is B0. This point here is negative B0. Okay? All right? Again, if I wanted to make that, this distance here is from the origin to the focus, that's C. This is B. And this hypotenuse is A, which is the same distance as this A from the center to the vertices, okay? We should know it, A, 0 to a vertice, the center. I keep saying 0. From the center to a vertice is on the major axis A. The center to the intersection here, we don't call it a vertice, is B on this minor axis. And then to the focus from the center is C. All right. My equation for a horizontal ellipse, A squared is always under the axis. A squared is the bigger number. It's the biggest. If the bigger number is under x squared, you have a horizontal ellipse. x squared over a squared plus y squared over b squared equals 1. Here's my vertical ellipse. X squared is over b squared, the smaller number, the smaller denominator. X squared over b squared plus y squared over a squared equals 1. Okay? Alright, so we kind of covered this before in class. We've worked these problems. Right, notice these are all for, notice there's, this is where h and k will be my center, and notice h and k are 0. This is for my origin. Both these equations, the center of the ellipse is the origin. Right, so now here's an example of a horizontal ellipse. Notice here's my origin, here's the center. So now this center, h comma k, we use this. So it's a horizontal ellipse, so a squared, the bigger number is under the x. And now it's x minus h squared over a squared plus y minus k squared over b squared equals 1. Here's your vertical shaped ellipse where the major axis is vertical. And notice this, it's going to be x minus h squared over b squared plus y minus k squared over a squared. This is the vertical. So all we did now is did the minus h and minus k for the x and y. All right? What time we got here? Okay. Got to get cranking. Let's do a problem. All right. Look at this. I've got x plus 5 squared plus 4 times y minus 4 squared equals 16. Our equations are always equal to 1, so I'm going to divide everything by 16. And that's fine and dandy because we did both sides of the equal sign by 16. We divided everything by 16. So now I've got x plus 5 squared over 16 plus 4 over 16. That cancels out to be 1 over 4. So that's y minus 4 squared over 4 equals 1. Where's the big numbers under x? So this will be a horizontal type ellipse. And my center, plus 5, remember it's x minus, that'll be my my hk, my center, is going to be negative 5, and then my k is y minus k is 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. There is the center of my ellipse, okay? Oops, daisy. A little technical difficulties here. Okay. A squared, blow this up just a tad. A squared equals 16, so A equals 4. You should all be on board with that. All right. B squared equals 4. A squared is 16, B squared is 4, so B squared equals 4, so B equals 2. Let's go work this equation. B squared equals A squared minus C squared. So 4 equals 16 minus C squared. We've done this before. Okay. So what is 16? The difference between 16 and 4 is 12. 16 minus 12 is 4. So C squared equals 12. And C equals square root of 12. Okay? Should be 3.5. Control square root 12, enter, is 3.5. If you can see that. Okay, so that's approximately 3.5. This will give us our foci. All right, horizontal ellipse. Okay. If I look at this, I might just graph this, make this a little easier for everybody to see. Okay, so we know my vertex is negative 5, 4. My center, my center, negative 5, 4. 2, 3, 4, 5. Okay, I might have messed up here. I think I did. Let's try this one. All right. 1, 2, 3, 4, 5, 4. Here's my center. And we said what? We have an A of 4. We know this is a horizontal ellipse, so my major axis is going to be this right here. Okay, it's horizontal. So I'm going to go 4 to the right, 1, 2, 3, 4, and 4 to the left, 1, 2, 3, 4. B is 2. Remember B was 2? Okay, so I'm going to go up 2, down 2, okay? And I can kind of draw this ellipse. Okay? The only thing I need to do is put C down. Here is, there's my vertex 1, vertex 2, and here is my foci are going to be 3.5 to the left and right of center. 1, 2, 3.5. There's 1, and there's 1, 2, 3.5 there. Okay, so let's list our vertices. There's the ellipse. Vertex 1 equals. Let's see, this was -5, and we went 4 to the left. 6, 7, 8, 9. -9, 1, 2, 3, 4. So we don't change on the y-axis. And vertex 2 equals, we were at -5 and we added 4. 1, 2, 3, 4. That's at -1, 4. And my foci, if I had to use a calculator, I would put -5 is approximately, I'll put down F1 here and actually show you it's going to be what? It's going to be -5 minus root 12, comma, that is my x component, right? -5 minus root 12, and then also the y component is, so that's the x, so this is the first one, F1, right? So it's -5 minus root 12, comma, 1, 2, 3, 4, and F2 equals -5 plus root 12, comma, 4, okay? What is that approximately for foci? Well, what's -5 minus about 3.5? That's about -8.5, comma, 4. And this is going to be -5 plus root 12 is going to be -5 plus about 3.5 will be about -1.5, comma, 4. So that's how you graph it, but this is how you can write it to be exact. Okay? Remember, when you approximate a radical like that root 12 in a rational number, you're kind of guessing. All right? So that's how we can kind of work problems when we don't have the center as the origin. We go plot things. We can still figure out A, B, C, or D. All right, and one last quickie, if I can squeeze this in, is, here we go. Here, sometimes I've been given a center of 2, -2, 2, -2. I've got a vertex of 7, -2, one of my vertices, okay? 4, 5, 6, 7, -2, okay? And a focus of 4, -2, okay? So from this, I've got an A of, this is my center, 1, 2, 3, 4, 5. A equals 5. My B, we're going to figure out, I've got this right here is C. Here's my focus 1. My C equals 2. Okay? So I can go ahead here and go, here's my center. I'm going to go 5 to the other side. 1, 2, 3, 4, 5. There's my other vertex, V1. Okay, we need to solve for B. B squared equals A squared minus C squared. B squared equals 5 squared minus 4 squared. I'm sorry, 2 squared. B squared equals 25 minus 4. B squared equals 21. So B equals the square root of 21, which is approximately 4.6, okay? All right? So for this, we're going to go up from the center to find B. 1, 2, 3, 4, and half, 4.6. Go down, 1, 2, 3, 4.6. There's B. So now I can draw the ellipse. Okay. Here's a focus here. Here's another focus here. F1, that's F2. Here's V1, V2. So I can get all my vertices. Okay. This is -3, -2. Okay, that's V1. V2 we already have got at 7, -2. Notice the difference between 7 and -3 is 10, and that's why we have, divide that by 2, we have an A of 5. F1 is going to be 0, -2. And my other one, which was given, was 4, -2. These are this focus 1, focus 2, and 4, -2. All right. So I've got all my points, and I plotted this B. If I need to get this point up here, is 2. The intersection on the minor axis, we went up 4.6. That's 2 and about 2.6. And then this intersection down here, which would be -2 minus -4.6. That'll be 2 comma -2, and then subtracting another 4.6 would be about -6.6. All right. So that's kind of working through these things. We were given a center, a vertex where I got A, I got the focus where I got B, and then I put them on the other side. They're all on the major axis, and we plotted this. Okay, that's a lot of stuff here, guys. So be ready for tomorrow. Okay, to be worked just problems with x minus h and y minus k. Okay, that's it. Thanks.